Okay, so for this one, it's very similar to the last one. And I could read what's in the textbook, but I bet you guys are smart enough to figure out what this means. Let's start unpacking this by labeling some things. So the domain, the domain represents something. What is the domain? It's time, and that's in hours, right? Oh no, years. Time in years. Okay. And then my range are the Y values. So what does that mean? I'm going to say measles cases. And it's per 100,000. So if you look at that, it says per 100,000. So when they say 10, they really mean 100,000. When they say 25, they really mean 2,500,000. Yeah, it would end up, yeah, it'd be in the millions, yes. So what do we want to look at first? Maybe this chunk here? Does that make sense to you guys? Now, I am going to read the context. So this is what it says in your textbook. You can read along quietly to yourself if you want, but on page 15 it says, the incidence of a disease is the rate at which the disease occurs in a population. It is calculated by dividing the number of new cases of the disease in a given time period, typically a year, by the size of the population. To avoid small decimal numbers, the rate is often expressed in large terms of people rather than a single person, i.e. 100,000 people. From 1974 to 1980, there were drastic fluctuations in incidence of measles in the United States. In 1975, there was a slight increase in incidence from 94. The next 2 years saw a substantial increase in incidence, which reached a maximum in 1977, about 26 cases per 100,000 people. I'm sorry, I misspoke. It's per 100,000. So when they say 30, it's like 30 over 100,000. I said it was 30 times 100,000. Okay, I'll explain that when we get into the context. So the incidence fell much faster after 1977 to 1978, and from 78 to 79. Finally, from 79 to 80, the incidence stayed about the same. Sketch the graph. Well, we have a lot of information here on the graph. Okay. I'm going to add more stuff. Okay. So I'm gonna make this. Let me make this just a little smaller. So there's lots of information here. We're really gonna focus on some stuff. So from here to here is the domain. So in order to do the domain, what is this point here? 0, comma 10. You guys get that? Does that make sense to you guys? What about this point here? Yeah, it's 1, comma. Yeah, we'll say 12 roughly. Let's do all the points while we're at it. What's this point here? 3, comma. No, it's more than 25, so probably 26. What about this point here? 4, comma 13 sounds good. What about this point here? That'll be 5, comma 5 maybe. And then this point here is probably 6, comma 5. Draw another little line like that. Now, I'm going to draw a thing called delta. It's really just a triangle. It's really just a triangle. And delta means, it's the Greek letter delta for capital D, but it means change. So we're going to talk about the change. Okay? We're going to talk about the change. Or you can also think of it as like slope. Okay? So the first thing we're interested in is our domain from 0 to 1, right? What's the corresponding range for that? (10 to 12), is that right? We're looking at the y values. So we're going, this is the x, this is the x, 0 to 1. So let's talk about that. This is the x value to the x value, that's 0 to 1. Then we look at the corresponding y values, 10 to 12. So when I look at the y values and I'm going from 10 to 12, what do you notice about those numbers? They're increasing. There is a difference, they've increased. So I want you to write INC for increasing and then draw a little arrow up. So when we look at a graph, we read it like a book left to right. If the slope is positive or it looks like it's going uphill, that means the y value is increasing over time. And then we say that the function is increasing. Let's look at the next little chunk. What do you guys think? You think we should look at this chunk right here? Yeah, good. You guys said, well, Mr. Adams, I know it's increasing. That's good. What's the domain for that chunk? 1 to what? Yeah, 1 to 3. So I'm going to say from 1, my x or my domain was from 1 to 3. What's my corresponding range? 12 to 26. Does that make sense? Is there any in here that disagree with that statement? So from x equals 1 to 3, our function is increasing. But you know what I'd like for you guys to do? Put 2 arrows because it's really steep. Right? It's really increasing. It's steeper. Now, what do you notice? There's one other thing I want to label at this point right here. This is called the maximum. It's the highest value on the graph. It's the peak of the mountain. You don't get any higher than that. Does that make sense? So if I were to ask you guys, hey, what's the maximum? When was there a maximum number of incidents? What year was that? 3 years after 1974, right? Which would be 1977. And if you remember when I read the textbook, it said it peaked at 1977. Okay? That's important. All right, let's do the next chunk. What's the next chunk you guys want to focus on? Yep, to the next point, 413. So, what's going on there? Is it increasing or decreasing? Going downhill, so that's decreasing. Draw an arrow going down. We're going from 3 to 4, right, on the x direction. What is my corresponding range for that domain? 26 to 13. I want to point something out before we move on to the next section. Here we're increasing, right? Notice my y value goes from 10 up to 12. Here we're increasing, right? notice that my lower bound goes from 12 up to, or increases to 26. Here we're decreasing. Notice that my y value goes from 26 and decreases to 13. See that? Okay, let's move on to the next thing. Let me change my color here. We're going to go from 4 to 6. What's going on there? Still decreasing, still going downhill. Okay. 4 to 6. Did I misspeak? Oh yeah, you're right. It's 5, right? 4 to 5. And my corresponding y values are 13 to 5. So, now, wait. Did I write this right? No, I did not. So we got to go back here. I'm sorry. I hope you wrote in pencil. Is this how we normally write this? No, the range goes from the lower bound up front. You could write it another way. So this is the tricky part. It goes from 13 to 26. That's how we're supposed to write it. And then this one goes from 5 to 13. I'm going to write it 2 ways. You would never do it this way, but I'm sure somebody out there is thinking, well, can you do it this way? The answer is yes. You can say, you're supposed to say 5 less than or equal to y, less than or equal to 13, but you could say 13 greater than or equal to y, greater than or equal to 5. You could do it that way. I can't think of a textbook written in America that would do it that way, but mathematically that's the same thing. Yes? I can't hear you, the fan's blowing in my ear. What's that?
Why was 13 changed to 26?
Well, because y, the value for y, because we've written it this way, the lower bound goes here, right? So when we look at this, we only want to know in this chunk, what is the lowest y value? What is the lowest y value? It's 13. So conventionally, we have to put the lowest value here, even though we're reading it this way. We have a tendency to read from left to right like we're reading a book, but by definition, if I say what's the lowest value for y across this domain, the lowest value is 13, and we would write it this way. Does that make sense?
Yeah.
So Ms. Adams made a very common mistake. I did that on purpose. I was pretending to be a student. But I made a very common mistake. Actually, you should write it the way it is now. But then I'm sure somebody was curious. Maybe they weren't. But there is another way that you could write that. So in this case, for the next section, we're going from 13 to 5, but 5 is the lowest value. So if we write this in set notation, we would put the lowest value first. Well, technically, the lowest value is 5, right? And then the highest value for this domain would be 13. That's for set notation. But I could write the inequality 13 is greater than y is greater than or equal to 5 because y lives between those two. Does that make sense? Okay. We probably should do it the first way. And so that's the hard part. If you write it this way, it's not that easy to see that it's decreasing for those two. Right? So if you follow the convention and you do it the right way, you can't look at these numbers here and see that it's decreasing. It's not that easy to see. All right. So now let's do, in other words, if I write this the way I'm supposed to, it looks like it's increasing from 13 to 26. But in actuality, it's decreasing. That's also why it's kind of important to look at the graph. It's easy to make a mistake. What you'll want to do in an upper-level math class like this is do the same problem 3 different ways, and if everything lines up, you're probably right.
Usually what happens, though, is if you make a mistake, one of the three things doesn't line up, or two of the three things, or none of the three things, and you go, wait, let me look at this again. Okay. Lastly, we're gonna deal with this little chunk right here. Right? We're gonna deal with that little chunk right there. What's the domain for that? 5 to 6. And what's the corresponding range? 5 to 5. So in that particular case, we just say y equals 5. Is that decreasing or increasing? It's doing neither, so we would say there's zero change. Zero change. It's neither increasing nor decreasing, so there's zero change. Okay? Some of you guys keep staring at the clock, hoping and praying for class to end. I emailed all of your next hour teachers, and they're going to let you do Algebra 2 until the end of the day. You're welcome.